there, I'm Jennifer Pulley, and welcome to another episode of NASA 360. On today's program, we're going to be talking a lot about alternative energy sources and how our current way of generating energy is negatively affecting the Earth. Now, unless you've been living in a cave somewhere, maybe you're living under a rock, you've probably heard tons of talk recently about the changing weather patterns in our world. You know, like global warming. Get this, right now, right this very minute, scientists from around the world are keeping their eyes on satellite data that shows growing trends of warming. And guess where most of that data scientists are studying comes from? You guessed it, NASA. That's right, about 75% of all global warming data comes from NASA's satellites, or NASA-sponsored research. Everything from specific satellites that do nothing but look for global warming data to the basic weather satellite, NASA is involved. Believe it or not, NASA has been keeping track of our weather for decades. When you watch your local forecast on television, what do you see? Pictures of our Earth being sent back via satellite, right? Well, that view's pretty common today. But it wasn't that long ago that people had no idea, no clue what our Earth looked like from space. Today, it's a totally different story. There are dozens of satellites and thousands of scientists helping us understand weather and global climate trends. And one of the leading scientists helping us understand global climate change is NASA's Dr. James Hansen. My partner in crime, Johnny Alonzo, rolled up to NYC, New York City, and caught up with Dr. Hansen to get a better understanding about what's going on with global warming.
Hey, if you're like me, you've heard a ton about global warming and global climate change, but you may not necessarily know what global warming is or what it really means. Let me try to break down parts of it for you.
The Earth's atmosphere is comprised of many different types of gases, like oxygen, nitrogen, carbon dioxide, and others. These gases have been in our atmosphere forever, but since the beginning of the Industrial Revolution, when humans started burning fossil fuels and emitting so much pollution, a change in the balance of gases in the air began to occur.
And when these levels started changing, something called the greenhouse effect intensified. Now, the greenhouse effect isn't necessarily a bad thing by itself. It allows Earth to stay warm enough for life to survive.
It works like this. When the sun's rays hit the atmosphere and the surface of the Earth, approximately 70% of the energy stays on the planet. The other 30% is reflected into space by clouds and other reflective things. But even the 70% that gets through doesn't stay on Earth forever. Eventually, it gets radiated out. Some of this heat makes it into space, but the rest of it ends up getting absorbed when it hits things in the atmosphere, like carbon dioxide, methane gas, and water vapor. But a major problem in recent years is that more heat is staying on the planet and can't get through the increased level of gases. Now, this doesn't sound like such a bad thing until you realize that even small changes in the planet's temperature can cause really bad things to happen. For example, ice melting in our polar regions. If the ice melts, some coastal regions, like parts of Florida or New York City, could potentially be swallowed up by the oceans, displacing hundreds of millions of people.
Ha! Scary stuff. But luckily for all of us, we have researchers all over the world monitoring the Earth's atmosphere to try to figure out what's going on with it. Now, one of those scientists is Dr. James Hansen of NASA's Goddard Institute for Space Studies. A key objective for Dr. Hansen and his crew is the prediction of atmospheric and climate change in the 21st century. Now, I went to meet Dr. Hansen near his office here in New York City.
Dr. Hansen's office is located just above the famous Tom's Diner from the Seinfeld show, but I spoke with him on the campus of Columbia University.
Well, the big issue that has come up in the last several decades is the fact that humans have now become a big player in the Earth's long-term climate. You know, scientists had thought that the Earth is so large that it's very hard for humans to impact the natural system, but it has become very clear that humans are now having an effect. And primarily that's through the added gases that we've put into the atmosphere, especially by burning fossil fuels. That's oil, coal, and gas. And that releases carbon dioxide and other gases and small particles, and these affect the energy balance of the Earth. The gases trap infrared heat radiation so that it tends to make the planet warmer. The planet has to warm up enough to keep the amount of energy going out from the planet equal to that coming in. And The result has been a warming of about 1.5 degrees Fahrenheit in the last 100 years. And we can see that there's more warming in the pipeline. You know, 1.5 degrees doesn't sound like much compared to weather fluctuations, which are 10 degrees or even more. That's fairly small, but it's enough to begin to have some long-term effects.
So what is NASA's role in your research?
Well, it's natural that the home planet is a place that NASA has been looking at from space for a long time. For example, there's just a remarkable satellite that was launched a few years ago called GRACE. It's the gravity satellite. It measures the gravity field of the Earth with such a high precision that we can see the change in the mass of the Greenland ice sheet or the Antarctic ice sheet and other things. Well, what we see is that sea level is now going up at about 3.5 centimeters per decade, which is, you know, in a century would be about so much. That's more than a nuisance, but the danger is that it could get to be much larger than that. If we keep adding more and more greenhouse gases to the atmosphere, the rate of melt will increase to the point that the ice sheet begins to collapse. And if that happens, sea level could go up several meters, which would be a worldwide disaster. Therefore, we need to figure out how these ice sheets work, and we need to figure out how much warming they can stand before they begin to collapse. That's the kind of thing which we can study with the kind of measurements that NASA is making.
Can we stop this process, or
can we stop global warming?
Can we at least slow it down?
We can do it. We could even stop it, not just slow it down, but it's not easy. Right now, the planet is out of energy balance with space because of these added greenhouse gases. So if we wanted this planet to stop warming up, if we wanted the Arctic ice to stop melting anymore, then we would have to restore this energy balance. Now, we could do that. So if we would decide, okay, let's really make a strong effort to reduce this air pollution, the things that damage human health, we could actually restore energy balance on the planet and stop the warming. But, you know, it's not going to happen unless people begin to ask for it to happen.
All right, so what are some of the things that NASA is going to be doing to help with the prevention of global warming?
Well, I think the most important thing is to continue and expand global observations. Okay. For example, although we have good measurements of greenhouse gases, we don't have good measurements of the small particles in the atmosphere. The sulfates and black soot, small particles that are produced mostly in fossil fuel burning also, but they reflect sunlight or absorb sunlight, and that affects the climate just as well as greenhouse gases do. And, you know, we're working on instruments that can do a better job of that. But we also need to continue measurements such as the gravity satellite measurements of the ice sheets, because it's very critical to understand how much warming they can stand before they begin to collapse. So we have to keep our eye on the planet Earth and really see what's happening.
Cool. So Dr. Hansen has explained how NASA is helping us recognize what's going on to our Earth. But what can we do to help? Well, we can do small things like use energy-efficient appliances and light bulbs.
And we can recycle and seal any areas in our homes, like doors and windows, that allow heat to escape. You can unplug so-called vampire electronics, like cell phone chargers, that suck electricity even when they're not being used.
And there are tons of things that we can do every day. We just have to start being smart about it. Other than power plants and industries that put so much pollution in the air, there is one other major source of pollution out there: the car. Cars pump millions of tons of pollution in the air every day, but we got to get around, right? So what are we going to do about it? Well, in big cities like here in Manhattan, you can take public transportation, like the subway. Or you can take buses, hybrid cabs. Yo, taxi! You can even bike or walk. But that's not the only thing we can do. How about developing a car that runs completely on alternative fuel, or just electricity? And no, I don't mean one of these little weenie golf cart type cars. I'm talking about a full-fledged sports car that can change the way the world drives today. Later in the show, I'm going to show you a car that is just like that. But first, we're going to dive down to DC to check out an awesome event called the Solar Decathlon. This event is so cool, it may help revolutionize the way the homes of the future are going to be built. Hang tight, guys. You're watching NASA 360.
So Hansen explained, conventional energy sources like coal and petroleum, oh, they're causing some pretty serious consequences for us here on Earth. So, we need to start thinking about using different types of energy, right? Energy that is renewable. From wind turbines that turn wind into energy to solar power that uses sunlight as energy. But unlike the wind that doesn't always blow when we need it to, the sun is always emitting light that can be turned into energy. We just need to figure out how to harness it. Back in the early 1970s, scientists started kicking around this really unique idea called a space-based solar satellite. And basically what scientists wanted to do was to build this huge device that could direct sunlight from space right down onto the Earth. And they would do that with a collection of mirrors and photovoltaic cells. And you guessed it, that sunlight could be turned into energy. At the time, back in the 1970s, it was too expensive. However, in recent years, new materials and computer technology have been developed that may give this old idea new life. So let's all keep our eyes on the sky for that one. Of course, there are tons of solar-powered devices on the consumer market already, right? I mean, new ones, they're coming out every day. In fact, some of these new solar technologies are being highlighted at a really unique competition called the Solar Decathlon. Johnny Alonso headed to Washington, D.C. to check it out.
All right, so we all know that there are tons of different types of alternative energy out there. But one of the most promising, solar power, or using the sun's energy to produce electricity. The sun produces lots of energy every day, enough to power 31 billion planets the size of Earth. Of course, we don't need that much power, but we definitely need to find a better way to utilize the energy that is coming from the sun.
Although you may not know it, NASA's on the forefront of a lot of solar technology. They're using it down here on Earth and up in space on satellites, on landers like the Mars rover, and on some new types of spacecraft.
Now NASA is finding really innovative ways to use solar power for its spacecraft. Dig it, one of the coolest is that are using solar winds to push spacecraft that are equipped with solar sails. Yeah, sails. So basically what this means is that a spacecraft is pushed through space by solar winds, just as the winds push a sailboat on the water back here on Earth. It works like this. The sun is constantly emitting light or photons. These photons produce pressure that, when reflected by the surface of the solar sail, push the spacecraft forward. Because the sail will have a non-stop source of energy from the sun, it is continuously accelerating and can reach speeds upwards of 155,000 miles per hour. This speed could cut years of travel time off long-duration flights and can help us travel to orbits that we could not have reached using traditional rocket power. NASA is also using solar power in other ways too, like running the International Space Station. Think about it. The ISS is up there right now, hundreds of miles above us in Earth orbit. How else would it be powered? It collects sunlight by using huge solar arrays. By huge, I mean over 260,000 solar cells to catch light, which is about half the size of a football field. Once it catches the sunlight, it converts it into usable electricity. The electricity runs the entire station, all the computers and equipment, and is also used to create the air the astronauts breathe by splitting water molecules with electricity. So perfecting the use of solar technology in space is a big deal for NASA. NASA has a pretty good grip on solar cells and electricity in space. But how does that help us back here on Earth? There are tons of companies out there right now that are using the same technology that NASA's using to develop solar cells so we can use them in our homes. So you want to know how we can use some of these technologies in our homes? Hey man, you're in luck. I'm here in Washington, D.C. at the National Mall checking out something called the Solar Decathlon. This is a competition consisting of 20 college and university teams to design and operate the most attractive and energy-efficient solar-powered house. So why does a competition like this exist? In our daily lives, we use enormous amounts of energy. The world consumes about 450 quadrillion BTUs of energy each year. Yeah, that's a lot. Right now, about 86% of that comes from burning fossil fuels like petroleum, coal, and natural gas, which are not renewable, and they cause pollutants that can cloud the air. Here in the States, we consume about a quarter of the Earth's energy per year, and about 21% of that is used in our homes. Now, that's a lot of energy, but there are many simple ways that we can learn to save energy. And there are simple ways to generate energy from renewable sources, such as the sun. So that's what the Solar Decathlon is all about, using clean energy from the sun.
I checked out a few houses here, including the amazing house from Georgia Tech. Why don't you tell me a little about this? Tell me what's going on here.
This is a competition sponsored by the Department of Energy. They invite 20 schools to participate in a student-run competition where the students design and build 800 square feet of a house, a solar home that's run entirely by solar power. It's an off-grid house, and we are here to participate in that.
Can you give me some examples of what this house is made of?
Well, one of the prime instigators of our design was to allow as much light into the house as possible, to maximize the power which actually allows the photovoltaics to work. So the elements of innovation that we've started looking into was the use of aerogel, which is a highly insulating but highly crystalline and light transmissive insulation.
What are photovoltaic cells and how do they work?
Well, these are solar cells that capture solar radiation and transfer it to electricity. And you see all the homes, that's what they're required to use. That's the whole premise of this competition. One of our mottos was conventional systems creating an unconventional house. So what you see here in terms of technologies, which if you take a look around the back door, most of the technologies that we've used in this house or brought into this house are off-the-shelf, high-efficiency systems. The key thing that we are trying to bring forward here is that the bang for the buck lies in how you use them over time. So we've spent a lot of time developing a control system that is that both educates and forces a user to be aware of how these things are being used and to be able to use them at the optimum level, because that's what makes the efficient house.
Okay, so far we've been talking a lot about how NASA and industry are using green technologies to help us pollute less and find smarter ways to capture energy. The one thing that we haven't really focused in on is once you capture the energy, how do you store it? You know, batteries. NASA's heavily involved in trying to make longer-lasting, durable batteries. Now, the reason's pretty obvious. So we can use these batteries on missions into space. For example, missions like the Mars exploration rovers capture energy from the sun on solar panels, and then store the energy in batteries for use when the sun isn't out. If the batteries don't work, then guess what? The mission's done. NASA's Exploration Technology Development Program planners are also interested in the development of batteries for such things as human-rated missions, to such places as the Moon or Mars. So these batteries have got to be the best, because they're going to be used from everything from astronaut tools to human habitats. So a ton of work is going into battery research at NASA. Now, NASA's research eventually will trickle down to be available publicly for future use. Now, luckily for all of us, scientists and engineers from all over the world have made awesome improvements in battery technology. One of the most important, lithium-ion batteries. These batteries are great because they last longer and are more dependable and lighter than traditional batteries. Today you can find these batteries everywhere, including in objects we use every day, like our laptop and cell phone. Another place that lithium-ion batteries are showing up are in cars. That's right, there are tons of car designers out there that are using it as their primary drive system. No gas, no oil, no toxic emissions, just clean electricity. One of these designers is my buddy Ian Wright. Ian has designed an incredible electric car called the Wrightspeed X1. This car is no joke. So here it is, the Wrightspeed X1. To me, this car is by far the most beautiful, environmentally friendly car in the world. To see it in person is awe-inspiring. The lines are beautiful, and it looks like a full-fledged race car, but it's completely street legal. This car is amazing. It's 3 to 4 times more efficient than a hybrid car, so that gets the equivalent of about 170 miles per gallon. And it's fast, too. In fact, it's faster than any other car on the market, with the exception of one, the $1.4 million Bugatti Veyron. The X1 can go from 0 to 60 in about 3 seconds, and from 0 to 100 in under 7 seconds. So you get a beautiful and fast street legal car that's also saving the earth. Not a bad deal. I caught up with Ian at the Altamont Racetrack near San Francisco to find out how this car works. So can you tell me some of the differences between traditional cars and this car?
Sure. So this car is a pure electric car. It gets its energy from the wall plug. It doesn't burn any fuel in the car.
Yeah.
The reason people build electric cars is that they're really efficient. And with this car, about 85% of the energy you take from the wall plug ends up at the wheels. Whereas in the gas engine car with this sort of performance, about 85% of the energy you pour into the gas tank gets thrown away as heat.
Wow.
So it's a lot more efficient.
The beauty of this car is that this battery, it's actually capturing energy and it's storing it, right?
Yeah, it's an energy storage system.
Okay.
The primary source of energy is from the grid, but when you're braking, of course, it's recapturing energy that you spent to accelerate.
Oh.
But yes, then it will store it. And it will store enough energy for about 100 miles. It's about 25 kilowatt hours.
So why is this possible today? I mean, what has changed?
Yeah, so we had electric cars 100 years ago, but they weren't very good. And up until about 3 years ago, the batteries just weren't good enough to make a useful electric car. And now they are. And they're getting better all the time. And it's really consumer electronics that drove the improvement in battery technology. You know, your cell phone that'll run for a week and doesn't weigh anything.
Right.
Your laptop that'll run for 5 or 6 hours and weighs only a couple of pounds. Lithium-ion batteries developed for those applications is really where it started and where it sort of got to be good enough that you could store enough energy to drive a useful distance.
How many batteries do you have here then?
There's 104 cells. It's a 436 volt system that weighs 538 pounds. This particular car you can plug into any wall socket you can find. There's only one gear and there's no clutch. So it's permanently engaged in this one gear, and you never shift, not even for reverse. The electronics just drives the motor backwards. So to drive it's very nice because there's never any messing about with the clutch. You're never in the wrong part of the power curve. The torque's always there anytime you want it. You can be just cruising along at 40 miles an hour, just put your foot down and go. The torque curve of the motor's so flat and so wide that the way it's geared right now, it's 0 to 105 miles an hour in first gear. So.
Oh, that's amazing. Have we covered everything here? Yeah. I think, let's go for a spin.
Okay.
I'm ready. Let's go. Nice. Oh my God, are you kidding me? Oh, this is banging.
Right up to the wall.
Dude, you are insane. That's a 360. I need one of these things. Oh, yeah. This thing was crying like a little girl. They should have heard me. Unbelievable. He's got like this great commentary. I'm like, all right. So that was pretty awesome, wasn't it? Sure is going to be hard getting back into my car after riding in that thing. Anyway, in this episode we've learned that NASA and others are working very hard to create new technologies to help better our world. But I hope we've also shown you that we just can't rely on the government or companies to keep making changes for us. That we've got to take responsibility in our lives and make changes in the world too. Hey, there's an old saying. The Stone Age didn't end because there weren't enough stones. It ended because people started using their brains to better their world. And so should we. Start using our brains to change our world. Hey, that's a wrap. I'm Johnny Alonso. I'll see you next time on NASA 360. I don't know what's wrong with me. I can do my lines today. Cool. And Dr. Hansen has explained how you don't get hit by a car.
My bud, Johnny Alonso, headed to... The first one was on. Start thinking... Nope.